All right, we're going to keep going with volume, get a little more practice. So, first type of problem we could have, you got to just find the volume of a rectangular prism. What do we need to do to find the volume? Length times width times height. A lot of multiplying. Go ahead and give that one a try. You said 24 and 3/8? 24 and 3/8 is correct. Just multiplying. 5 times 1.5 times 3 1/4. All right. With a calculator, as long as you're entering in things correctly, especially with the mixed numbers, should not be a problem, right? Any questions on that type? All right, so the second type of problem we could see then is working backwards. When it gives you the volume and has one of the measurements missing, what do we need to do on this? The opposite, so we are dividing. Go ahead and give that one a try. Using a calculator, if the answer has a fraction to it, it's going to give it to you as a decimal. So make sure you hit that F to D button to get it back to a fraction. And we get 4 and 1/8. We do 165 divided by 16 divided by 2.5. All right, so those are the first two types of problems. Those are the ones that were in your workbook. Those are the ones that you're probably the most likely to see. There are a couple other things. The third type is the ones like this, where you're trying to see how many smaller boxes fit in a bigger box. So there's 3 main steps to this. Step 1 is to find the volume of our big box. We find the volume of our rectangular prism here. So we do length times width times height. So 4 times 1.5 times 3.5. And what do we get? 21. All right, so that's the big volume. We get the volume of the little box, the cube in this case. It says the side lengths are 1/2, so we would do 1/2 times 1/2 times 1/2, which is 1/8. That's step 2. It's not always going to be a half. It could be any sort of fraction for those side lengths. You just multiply it out 3 times by itself. What we're trying to find is how many times the little box can go into the big box, or how many of them can go into it. When we're going into something, that's division. So we do 21 divided by 1/8. That gives us 168. So that's saying we could fit 168 of those little cubes into the big box. Any questions on that one? It's not a completely different type of problem, but another problem we saw a little bit of yesterday in our classwork was one that looks like this. We got an aquarium. It has dimensions of 14.5 long, 22.5 wide, and 10 inches tall. So in this case, we got 14.5, 22.5, 10 tall. My picture doesn't exactly match it, but close enough. She's filling her aquarium with water, leaving 2 inches empty from the top. So we got our water, kind of filling it up. What we left, like I said, was 2 inches. All right. This is asking us for the empty space. So since it's asking for the empty space, we're basically looking at the volume of just this little piece right here. So what's the height of that little piece? 2. The height is the 2. We still have 14.5, and we got 22.5. So we do 14.5 times 22.5 times 2. $652.5. Okay, so this was asking for the empty space. I have seen similar problems, like I said yesterday, on the 8th grade EOG, where it asks for the liquid. So in this case, it'd be the water. What you have to remember is if it's asking for the liquid, the whole thing was 10 inches. So if we stop 2 inches from the top, that leaves there 8 inches of water, so you'd use that number for the height instead. So 2 kind of different ways you could see a problem like that. All it is finding the volume. You just have that extra step in subtracting or using the 2 inches.